On this example, we're going to use implicit differentiation to calculate dy dx. So as you can see, we have multiple different terms in this equation, some having y's, some having x's. Should be a pretty straightforward problem, so let's walk through it step by step. So one term at a time here, let's look at the y squared. To take the derivative, we're going to use the power rule, and we're going to get 2y raised to the first power. However, because our variable was y, next to this we're going to put a dy dx. All right, next, move on to that next term. We have 9x to the third power. Again, power rule, we can bring the 3 down in front, multiply it by the 9, get a 27. Reduce the exponent by 1, so the 3 becomes a 2. Now next to this, because our variable was x, we could put a dx dx, but we typically don't do that because that's the same thing as a 1. Same thing, numerator and denominator. Moving on to the right-hand side, we have 2y. The derivative of this linear part is going to be a 2, but do remember our variable is y, so we could put a dy dx next to this. And then finally, last term here, the negative 4x to the second power. Again, power rule, 2 comes down, gets multiplied by the 4 to make an 8. Reduce the exponent by 1, so we get an x to the first power. And again, this is what I was talking about. We could put a dx next to that because that's our variable was x. We're differentiating with respect to x. But same thing, numerator and denominator becomes a 1, so we don't typically write that next to it. All right, from here, we can treat this as though it's a linear equation. The dy dx is treated as our variable, and then everything else, kind of treat those as constants. So we want to get all the terms that have a variable on one side. I'm going to go ahead and choose to put those on the left-hand side. So I'm going to subtract 2 dy dx from each side. All right, this will put all of our dy dx's on the same side and eliminate them from the right-hand side. And I'm also going to go ahead at this point, and this term that has just x's, I'm going to move it to the right-hand side by subtracting it. So subtract 27x squared from both sides. So again, adding and subtracting the same thing goes away. So what are we left with on the left-hand side? We have 2y dy dx. And then we subtracted 2 dy dx. And then over on the right-hand side, we had negative 8x, and we've subtracted away 27x squared. All right. As you'll typically find when you're doing these problems, after you've put all the dy dx's on one side and everything that doesn't have one on the other side, now you can say to yourself, we have a common factor on the left-hand side. Doesn't have to be the left-hand side, just on mine it happens to be that both of these terms on this side have a dy dx. So what you can do is factor that common factor out. You'll be left in this case with 2y minus 2 equals negative 8x minus 27x squared. All right, almost there. We now have dy dx connected with multiplication to everything else on the left-hand side. So to get rid of the 2y minus 2, we can divide both sides by that. All right, in doing so, multiplying and dividing the left-hand side by the same thing, we're going to be left with dy dx on one side all by itself, and it's going to equal what we have over on the right-hand side. We could do a little bit of factoring out of a common factor of that 2 as well, but when it comes down to it, that is our derivative dy dx. So I hope this helps out as you're working on learning implicit differentiation. Good luck.